Okay, we're in section 39 of the notes, and we're taking a look at the examples of how to find. Let's go back to the section over here, volumes of revolution. We're using what's known as a disk method. So, certainly we presented some lecture material in classroom. A lot of students find this difficult. The problem with is visualizing it. I do want to point out books have really good, these pictures have been lifted off a book. I can't remember which book I lifted it from, but a book that we use at Essex County College. So the bottom line is that, nice pictures are good. I'm still going to be drawing my crappy pictures at the board. The reason for that is when I get to an exam, I got to be able to do this without pictures. All right. I got to be able to visualize myself. How do I do that? Chicken scratch pictures, but I really need to set up an integral. The big issue here is setting up an integral. So we're going to go through the example number 1 and example number 2. And then, of course, there'll be a chance for you to try on your own. And I can't say this enough times. If you're not trying, you're not learning. You've got to try what we're presenting to you. And you need to do that on your own, all right, independently of me. However, if you're really struggling and you need additional support, please come by during office hours, and I'll be more than happy to help you. So let me get to my whiteboard. And I'm going to go through my steps that I'd go through to do the problem. I think if you go to YouTube, you might see other people have different steps, but the first thing I'm going to do is, I'm not trying to memorize anything. I'm trying to, can I get a picture of what they're talking about over here? So, it's chicken scratch again. And looking at this thing over here, I noticed I got 2 curves down here, and they're talking about a region. And the first curve that's easy for me to draw is y equals 8. That's y equals 8. That's right over here. The next curve I see is x equals 0. And I kind of figure what that looks like. What does x equals 0 look like? Well, it looks like this line over here. And that's x equals 0. That divides this coordinate system into 4 parts. All right. Then what do you see? You see a cubic. And that's a little more difficult to do, but I think I can handle it. And I'll put this over here. Cubic looks sort of like this. No, I'm not saying I'm doing a great job of it. Now, immediately what I notice is I've got a region now. And this is the region they're talking about. And I want to put the points down of that region. And there's going to be 3 points I see. And I want to just be careful about it. All right. So I'm going to put this point over here. That point over there is 0, 0. This is why in prior course you spend so much time graphing so you can get a rough idea what you're looking at over here. This would be 2, 8. And this point over here would be 0, 8. All right. Now I have to read it to you. What does it say? It rotates this thing about the y-axis. So the first thing I got to do is I got to visualize what's called a disk. And the way I do that is I draw a rectangle like this. And then I wonder if I rotate that about the y-axis, what would that look like? It would look like a disk like this over here. The next thing I do is I look at the differential, and I can say it's along the y-axis, it's really dy. So the thickness of that disk is dy. Then what's over here is r. What's the volume of that disk? V equals pi r squared dy. Well, now I got to wonder what the y is. It's got to be in terms of y. The r in terms of y. So really, all it is the x coordinate. Now, someone says, "What's the x coordinate?" Well, I want to point out that y, I'll write this over here, equals x cubed. All right. So what's the x coordinate? The x coordinate would be the cube root of y. So I'm going to put that in now. The volume of the disk. We're just talking about this disk over here, is pi cube root of y, which is y to the 1/3 squared dy. All right. What am I going to do now? I'm going to start adding these things together using an integration. Now, someone says, what's the integration going along? Let's take a look at it. Let me get back to black. And we're going along the y. So let's put this down. It's going to be pi. I'm putting this down now. I'm adding things together. Y to the 2/3 dy. Let's look at our picture. The y's are starting at, sorry about that. The y's are starting at 0 and they're moving up to 8. Let me point out what I mean by that. If you look at this over, we're moving along the y's. This is y equals 0. When up there, I get up to 8. All right. This is going to represent the volume that they're talking about. And let's see if we can do the integration now. What do you get over here? Pi. Increase the exponent by 1. So that's y to the 5/3. You're going to divide by 5/3 or multiply by 3/5. 0 to 8. Whoa, this is going to be a tough one, isn't it? We'll take a look at it over here. It's going to be 3 pi over 5. I want to talk about y to the 5/3, what that means to me. That actually means y to the 1 2/3, which means y cubed root of y squared. Where'd you learn about exponents in Math 100? So let's see if we can do that. All right. So I'm looking at the 8. Right. So what's it going to be? 8 times, well, the cube root of 8 would be 2, and 2 squared would be 4. Minus, well, the lower limit couldn't get any better. It's just 0. That evaluates to 0. So what do you get over here? Let's see. 8 times 4 is 32. 32 times 3 is 96 pi over 5. Do mistakes happen? All the time. This is why we give you a key, and this is why we want you to look at the key to verify that you got the right answer. If you're not getting the right answer, all I can say is do the problem again. What I say, 96 pi over 5. Bingo. All right. Let's do the next one. Again, I know they're providing pictures. These pictures were lifted from a book, but I still want to do the story. What's the story going to be? Visualizing. After you visualize, how's it being rotated? When I say visualize the region. How's it being rotated? Can I get a disk to get that? All right. So over here, let's take a look at it. Y equals X, fairly simple. I'll write that down for you. And I think you probably can appreciate my graphs are pretty simple. They don't have to be great. That's Y equals X. And the other curve is Y equals X squared. Looks like this over here. And immediately I see a region. And what's the point over here? 0, 0. And the point over there is 1, 1. Let me just shade the region in for you. This is the region. I'm not sure what they're going to do with that region. And I don't know that until I read. So they said the region is closed by the curves, Y equals X and X squared. I did do that. Then they said rotate about the X axis. I'm going to visualize that now. What I mean by visualizing, it's rotated like this. This is the X axis. So the way I would do that is I would draw a rectangle. And let me do that for you. Now, what do I notice if I rotate that region around, I do get a disk. But what I get is I get a big disk. I get this big disk over here. Let's talk about the big disk first. All right, the big one. All right, so what do we get over there? Well, it's going to be, the differential is going to be dx. Again, I'm doing that big disk now, that big red disk there. It's going to be dx, and my disk is going to be starting at 0 and going up to 1, and then pi r squared. Now, what's the r over there? The r is actually what the y coordinate is. And what's the y there? Well, if you look at it, y is just equal to x. All right. I have to now subtract away the smaller disk. I want to point out I'm subtracting away this disk over here now. So I got to punch a hole in it. So I'm going to go 0 to pi dx. And what do you over there? Pi r squared. All right, I'm doing that disk. So what's the r squared? Again, I'm still getting a y coordinate here. What's y equal to? Y is equal to x squared, isn't it? So I'll put that down. All right, let's do the integration. As I do that, I'm going to rewrite a little bit differently. I'm sorry, I said 0 to pi, and I just have pi on my brain, and I got to erase that now. That's not true. I'm going 0 to 1. Clearly as indicated in my picture. Clearly as indicated in the picture. Mistakes happen. That's why we have the keys. So it's going to be pi x squared dx minus pi x4 dx. We're going 0 to 1. And we got to do the integration. It's going to be pi x cubed. That's a cube. Let me get my eraser. It doesn't look right. Zero to 1 minus pi x5 over 5, 0 to 1. Let's keep doing it. Again, we have an answer key. We'll look at that. This is going to be pi over 3. 1 cubed is 1 minus 0. That's pretty simple. Minus pi over 5. 1 to the 5th is 1 minus 0. Because 0 to the 5th is 0. What do you get? Pi over 3 minus pi over 5. And what do you have there? 15 would be common denominator, right? Then you get 5 minus 3, which is 2 pi. And that's cubic units, by the way. Let's take a look at the K. All right. Again, what are we looking at? We're looking at an answer over here. Okay. I realize for a lot of students, they say, do another example, another example. Yeah, That's right. You got to do more examples. But what I'm saying, you got to do more examples. Try the homework, practice. Now, I realize someone says I can't practice. Well, here's the deal. There's no way to learn the material unless you practice here. Practice exactly what I've been doing. I'll also post videos over here, and that'll be a video on the homework. If you need to watch that, you can watch that. If you need additional support, come by during office hours, and I'll be more than happy to give you additional support. But you just can't come by and say, you know what? I don't understand anything. You've got to try before you know you don't understand something. And trying takes a lot of time and effort, and we're trying to encourage that. Thank you for your attention and good luck.